So hello, I'm Aleksandra. I'm acting COO of the Golem Factory, and I'm here to answer some question which we have been asked many times before. So first, to get to know you, how many of you have heard about the Golem project before? Okay, and how many of you have used it actually? Oh, I really hope that I'll be able to encourage you to try it out finally. So let's start with the first basic question. So what is Golem? We are one of the oldest Ethereum dApps. Actually, we have the first presentation about the idea at DappCon 0 in 2014. Then we got crowdfunded in 2016, which allows us to scale up the team significantly and speed up the development to be able, to actually build the idea that we had in our minds. So what's the idea? The idea is to connect all the computers across the globe to create one global market of computing power. It's not a new idea. Like, basically, during the BitTorrent phase, people were trying to do something like that and to add the market to the torrents. But what was missing during that time was this distributed consensus. Later, when Bitcoin was born, the distributed consensus for payments was finally in our hands. And later, with Ethereum, we got the consensus that was not only on the payments layer, but on the state and logic layer. So having this one additional component, we finally have tools that allow us to make this vision a reality. So, to sum up, there are three types of users in the Golem network. The first group are requesters. Requesters is anyone that needs computing power. It can be an engineer, it can be a scientist, it can be a blockchain validator that requires a huge amount of additional power. The next group are providers. Provider that is anyone that have unused computing power. So it can be an individual user that has a powerful PC, or it can be a small data center that is looking for additional possibilities. It can be unused mining rig, for example. And the last group are developers. So anyone that's willing to share her or his code with the network, maybe to promote it, maybe to monetize it with a new model, for example, by getting micropayments every time the code is being used. When we have all these groups connected together, creating one common market, that's the ideal vision of Golem network that we're trying to build. So, no. Okay. So where are we now? We're on mainnet for more than a year. Actually, we're having 3 working use cases right now. Rendering is on mainnet, and 2 additional use cases are on the testnet. So scientific computation, and a really powerful one, GWASM, so WebAssembly computation. And how can you try it out? It's really simple. Just go to this site that you can see here and install it and test it. We have version for free operational system for Windows 10, macOS, and Ubuntu. We have a graphical user interface if you want just to set your options as a provider. And we have a command line interface if you want to try something more advanced and more complicated. If you want to automate stuff, or if you want to test out this new use case that is called GWASM. We have also additional product that is called Golem Unlimited. And this one is for a powerful provider. So if you have more than one machine, if you have, for example, a company with a set of computers, or if you have computers in a lab and you want to install Golem on all of them, just choose this solution. And you can use it separately just to distribute the computation in your internal network outside the market, or you can connect it to the Golem network via Golem Unlimited Hub, the big one that you're seeing on the picture. And then your whole network of computers is represented as one powerful Golem node for the Golem network. Link to this one you can also find on the sites that I mentioned here. Okay, so the next question, how can one integrate with Golem? Because those two were for requesters and providers, so the top layer of this triangle that I was showing. What if you're a developer and you want to add your code to the Golem? And the answer is use WebAssembly. Write your code in WebAssembly and just put it in the Golem network, like the new use case that is live for more than a month allows you to do it. So you just check our documentation, how to do it exactly. It's quite simple. The good news about WebAssembly is that you can compile the code that is written in other languages. So if you have a code that is written in C, C++, or Rust, you can just compile it to WebAssembly binary and use it with Golem directly in the same way you're using normal WebAssembly code. And what should you do in case that you don't want to write anything in any of these languages, or if you want to do something more complicated? Then you have to wait a little bit longer for our task API, so the next big Golem release that is going to be called Clay. Task API is under development. We can expect the first version this autumn. And then like the amount of possibilities that will be open after that will significantly increase. So how this task API is going to look like? What functionalities can you expect? And here you can just see a short preview. It's going to be really, really simple. So basically the app that you're going to create should be able to answer this simple RPC call. So you will be asked to create a new task in your application, then give Golem the next subtask for computation. If there's a provider willing to compute it, then to verify the results. Run some basic benchmarks to estimate how powerful is your machine comparing to other machines in the network. Just like that. As I mentioned, keep track this autumn. There should be some updates about Task API. Here is my favorite question. So how are you gonna verify my computation? Because there is this verify function that you've seen in Task API. And there's no one single simple answer, because it can get quite complicated. For example, for our first use case, that is rendering, we have this pretty advanced verification algorithm. So actually, requester is rendering locally small parts of the image, then compare it with the result that he gets from the provider, run a machine learning algorithm that is giving him a verdict. Because in rendering, there is a high risk of some indeterminism, so there may be some differences in the pixels. That's why it's so complicated. Fortunately, it won't be like that with other use cases. With WebAssembly, we're in a pretty good place because it's relatively easy to make WebAssembly code deterministic. Check our documentation. There are some just edge cases when your code may not be deterministic, especially like there might be some problems with nonce, but not on the standard architectures. So what we're doing for WebAssembly, we are introducing some level of redundancy. So more than one provider is computing the same subtask. We're comparing if the results are the same. It looks simple, but of course underneath it there is like mathematical model and specialized algorithm. If you want to know the details, please check our blog post about redundancy verification. How much does it cost to use Golem? Unfortunately, I won't give you any specific numbers because Golem Factory is not the one that is setting the price. The market should be self-regulating. That means that the requester decides how much does he want to pay for the task. with some use cases, there is a fixed price. If you're able, as a requester, to estimate how long your computation should take, then the fixed price is the right model for you. So you're just setting, that's the time out of my task, and I'm willing to pay that much for the results. And you'll get the results as soon as possible. That's a good model for a requester, but only if he's actually able to estimate it. So that requires some heuristic knowledge about your code and about estimation of what kind of machine do you need to actually execute the code in this time. If you're not able to guess it, then the solution is our pay-as-you-go model, where you're paying for an hour of computation. Of course, there's a still risk that provider may cheat you and fake declare more hours of computation that actually was done, but for that, also there's a mathematical model underneath it. We have a series of blog posts pay-as-you-go, where you can check the exact equations. Yeah, but it generally should be better in case you're not able to guess. My second favorite question is, how are you going to protect my data? And this question is relatively easy for providers. So you want just to isolate the code that is being executed on your machine from the rest of your machine. So that's a pretty classical problem. And the only natural answer is sandboxing. So like some typical sandboxing virtual machines, Docker containers, other containers, WebAssembly sandboxing. We can discuss the level of security that we're having here, but that are pretty standard solutions. The more interesting question is, how are you going to protect the data that you're sending as a requester? So how are you going to protect your code? How are you going to protect the data? If you're sending your data to the cloud, you're not getting that protection. You just trust the cloud provider. And that's something that we can introduce in Golem. We can add some form of distributed identity, distributed licensing, so you can just compute your code on the machines that you're trusting. But I believe that we can do better. And the answer to this question is trusted execution environments, so enclaves. This technology is still at its quite early stages. It's being developed actively, but that's the way how we can get a hardware solution that guarantees the privacy of our code. That can also be the answer for the verification. So better solution for the verification, because this way you're sure that your code was actually executed and that the code that you actually sent was executed and not in a not modified way. We're trying to work on a solution called Graphene that is going to make the usage of trusted execution environment easier. And we really, really hope that that's going to be an answer for our network, but not only for our network. That's something that's going to become a standard for the cloud computing. What external components are you using and which are you building in-house? That's the question that we got from our community. Because Golem is quite complicated. There are many layers and many components, and for a long time we were building many of them in-house. So most of the Golem code is something that we were building from scratch. But of course not all of it. As I mentioned at the beginning of my talk, the Ethereum was this missing market distributed consensus component that we of course use. So we're using Ethereum for payments. We're using Ethereum for deposits in additional verification services. We want to use Ethereum more in the future for licensing models for this distributed identity. Maybe for something more, we'll see. We used to have our own peer-to-peer network implementation, but that's not the way to go any further. If you want make sure that the Golem is going to become a standard, we have to use a standard networking protocol. So we are actively working on switching to libp2p because libp2p made enormous progress last year. So the migration to Golem from our internal P2P2 network, as we call it, to libp2p REST implementation is also coming quite soon. And based on that, we're going to build this resource transfer layer because it's still our internal implementation right now. And we want to add like forehand protocol on top of libp2p. For sandboxing, as I mentioned, we're using standard solutions here. So fully external implementation. And for this security, verification, data protection, we're working with our subcontractor, Invisible Things Lab, and with Intel to work on a graphene project that is going to make this usage of distributed trusted execution environments easier. And the most important question, why should I choose Golem? You should choose Golem because with the demand and offer language that we're going to introduce soon, you're going to get a freedom of choice and a voice to specify what are your requirements about computation. Because right now, if you want to rent a computing space, you have an offer that you get from a data center. The provider has a voice, but the requester only if it's a very big company. If you're a single customer, you don't have a tool to specify what exactly do you need. And if you don't have this tool, then the person that is offering you your computing power may ignore your needs if it's not important for them. If you have ability to say what you need, you can say that you need, for example, privacy. So something that won't be important for a big corporation. And if you create a market that's going to be self-regulated, you get again this freedom to set the price and set your requirements. And the last but really important question. What end game looks like? How the world is going to look like in the future? How do we want to imagine the future of Golem? Well, usually in science fiction, you've got this dark anti-utopian vision where you get corporations, where you got syndicates that are taking over the world, that are holding all your data, that they know everything about you. If we don't want this future to become a reality, we need tools. We need tools for privacy, we need tools for protection, we need tools that can give us the freedom and voice to say what we really need. If we need the price, that's good. If we need privacy, say that we need privacy. And what we hope to achieve in Golem is to build this tool, to build the network that can connect all the computers in the world, and where Golem Factory may just be one of the players, but not someone that is holding everything and deciding about everything. And I really hope that you, with your distributed projects, you're here because you're building these tools and solutions as well. We don't need these solutions right now, but we will need them in the nearest future for sure. So I hope that together we will be able not to have this dark anti-utopia, but just have the tools that we need. Okay. So thank you, and I would like to thank all the Reddit users that I mentioned here that asked us some questions and helped me to prepare for this presentation. And if you have any questions that you would like to ask.
When you do sandboxing, do you still create some attack vectors from provider, like you share RAM or something, cache, so that they still can access data? No, I mean on the side of computer power provider. So they still can access some of the data through RAM or cache sharing, something like this.
Depends on the level of sandboxing. So we're having different levels. We have virtual machines that should protect everything.
Okay, and what do you think about homomorphic encryption for these purposes?
Well, I think that's the question that you should ask to Łukasz that is sitting over there. He's the head of our research, and he was like actually making some research about that on the Golem Unlimited.
Thank you. Right now, for rendering engines, you only support Blender, right? Is there any rollout plan for like V-Ray or maybe other render engines?
Technically, it should be quite easy to implement it. What we are also researching right now is distributed licensing model, because all these commercial services, they can connect, but they need good market incentives. And we have this proposal where you can just create a short-term licensing model on a blockchain that allows you to share your commercial license for a short period of time with a large amount of users. And we like working with lawyers intensely to create a proposal. And with this proposal, we will address more commercial solutions in the near future.
Cool. And right now, you only address CPU power, or you also address GPU power?
We address GPU, however, it's like limited to NVIDIA in a specific version.
Mm-hmm.
Does it come into play in this exchange, the Golem token?
The token is used for the payments model. So like you're paying for the computation with the Golem token. Yeah. Also for these additional services, like I mentioned, additional verification service consent that should finally go live also really, really soon. And you pay for this service with this token as well.